The thing about the improbable is that it's not probable. And I want to share with you some wishes about the improbable. Let me go back in time to the first time I visited the Balkans. I didn't need a passport. I just had to go to Emeryville to meet with a team that was developing a drug for treating malaria, a vertically integrated pharmaceutical startup, if you will. And they had a crisis. Their funder had to spend more money right away. And so they came to their advisors, of which I was one, and asked, how could we spend more money on this team? And the thing that was really interesting about the project was the drug they were developing, resistance in nature to that compound, had already emerged. And so you could foresee that they would have to do the project again and again and again. And what was doubly amazing was how much work it was to do such a project. It was about 150 PhD years of effort just to make this one compound. And that was fine because you could afford to pay that many people. But the task of organizing the team, having the people who knew that the drug could be developed in the first place and then knew the science and the biochemistry and the genetics and how to bring it to market, wow, that's kind of tough, organizing people to do stuff. And so I gave them the best advice I could. Please invest in this team right now in making platforms so that the next time you have to do this project, which is right now, it's easier to do. And I thought this was a really great idea. The worst advice I'd ever given. The team said, no way. And the money said no way. The only way we'll spend more money or take more money, both parties said, was if we bring this drug to market 1 week earlier, because every week we delay, this many more people have died. Since then, I've helped start biological engineering at MIT and at Stanford, iGEM, and BioBricks, and so on. Tomorrow I have to go back to Stanford and I have to teach the first-year undergraduates Introduction to Bioengineering, which we've renamed Engineering Living Matter. Now, I can imagine living in the future where we've made living matter fully engineerable, but tomorrow I have to go tell them about printing DNA from scratch and how difficult that is with the tools that we have. But what's interesting about these students is they represent part of a sustaining community that for the first time in the engineering of biology has begun to work on the problem of solving problems. Not just the immediacy of the application, which is typically overdriving and very pressing in bio, cure the disease, save the environment, do it right now. But the problem of solving problems is a secret of how we sustain exponential improvements in our capacity to do stuff. So let me end with 2 wishes that I have. It's easy to imagine a future where we have this ThinkJet desktop DNA printer that's programmed with light, and you can make any piece of DNA you want on your kitchen counter or your bench or whatever it is. Right? Maybe you're doing biosynthesis of morphine in the yeast in your bread machine to have personalized pharmaceutical companies. Right? Maybe you're doing something else. Well, what do we wish for about this future where we've made living matter fully engineerable? I have 2 wishes. The one is it's a future of citizens, not consumers. Biology has a potential to realize distributed manufacturing, which it does in nature on a massive scale. And that allows us to flip a trend which has been going on for the last century, disempowering individuals. The second wish I have is that when we think about ourselves, we think beyond ourselves. Apparently, during my lifetime, half of the animals on Earth are no longer on Earth, collectively. And to think about humans and biology without thinking about the rest of the world is insane. Thank you very much.